The cochlea is part of the inner ear, and it is called the cochlea because it is snail shaped. But this is what contains, so this is the inner ear, and it contains hair cells. So I mentioned that the sound waves are transmitted into the cochlea via the oval window, and then they travel and they vibrate different parts of the cochlear membrane, bending different hair cells. And that difference in the bending of the hair cells gives us a perception of pitch, high sounds and low sounds, as well as amplitude, which would be how loud the sounds are. So let's look at this structure of the cochlea. You do not need to know all of the details about this, so we're just going to just very quickly talk about it. So this is my oval window right here, right there, and the sound waves are going to be transmitted in. And the hair cells are actually covered by a membrane. And as this membrane vibrates, it's going to cause these hair cells to bend. And when the hair cells bend, that is when an action potential is going to be generated and sent via the auditory nerve to your auditory cortex. And so when we look at this cochlea, we have some hair cells that are at the base of the cochlea. And then as we travel in towards the center, some hair cells that are at the apex. And so the base of the cochlea has hair cells that absorb high frequency sounds. So just as an example, the base of the cochlea absorbs high frequency sound waves. Okay. The apex of the cochlea absorbs the low frequency. Some people have likened this to a musical instrument, maybe like a harp. So the higher pitch, lower pitch has to do with the strings on the harp, right? And so this is like your musical instrument of your ear. Let's look at a diagram that shows that energy. So here is my I should use this one. Here is my oval window. The sound waves come in. These high frequency sound waves are going to generate action potentials right there. As they move up, maybe it's a lower frequency and it's going to generate an action potential there. And then the sound waves need to come back out and exit the ear. Otherwise, because this is fluid filled, if there was not a way for the sound waves to exit, and this is just a membrane, a thin membrane that vibrates, right, the sound waves, then you wouldn't be able to, it would be like you wouldn't be able to displace any of the fluid. And so it would not be able to transmit sound waves into this inner ear, into the cochlea. So that round window is actually kind of important. So here you can see sound waves coming in. They're going to vibrate here, the tympanic membrane, the eardrum. And then we're going to vibrate and move those ossicles, the malleus, thincus, and the stapes, and then the sound waves get sent into the cochlea. So this is how we are able to perceive sounds.